Section 6.5. We're going to solve trigonometric equations by various methods. I want to find all the solutions in radians for sine of x is equal to 0. Remember, sine is defined as the opposite, or the y side, over my hypotenuse, or my r side. That's what I have written here. Okay? So if y over r is equal to 0, remember, then that would have to be 0 over some number. So y would have to be 0. So we want to know where y is equal to 0. Think about the unit circle. It's one of these quadrantal points. Remember, here is a point 1, 0, so there's y 0. And this is negative 1, 0. So that's also y 0. So around the unit circle, y is equal to 0 on that x-axis, or at 0 and pi and 2 pi and 3 pi and 4 pi and so forth. At 0 and pi and 2 pi and 3 pi and 4 pi, and I can keep going on infinitely around the circle. But you can't write them all because it goes on forever. So you can write them as 0. To get over here, since it's 180 degrees or pi radians away, I could add pi to it. So I could write it as n times pi. So when n is 0, I'm here. When n is 1, I'm at 1 times pi of pi. When n is 2, I'm all the way around the circle at 2 pi, and so forth. So there's my solution. Next one, cotangent of x is equal to negative 1. Remember, cotangent and tangent are reciprocals. So this is the adjacent side over the hypotenuse, or opposite, or the x side over the y side. As I said, remember, cotangent is the adjacent over the opposite. So here, to get negative 1, we know that the fraction is equal to negative 1 over 1, or it's 1 over negative 1. Those are the two ways that you can get negative 1. So here, x can be 1, and y can be negative 1, or x can be negative 1, and y can be 1. Either way, it works out. So now that I know that, negative. Remember, around the unit circle, I'm negative in the second quadrant. I'm also negative in the fourth quadrant. So there's my there's a picture of it. So I'm in quadrants 2 and 4, and my reference angle is 45 degrees, or pi over 4. So in the second quadrant, my angle is, in radians, 3 pi over 4. And in the fourth quadrant, my angle is 7 pi over 4. So if I take those two solutions and write them in a general solution, to get to this one, I could go here, or I could go all the way around the circle and back to here. So I could always add 2 pi to that. So here's one general solution, because I can add many 2 pi's. I can add 2 pi's. I can add no 2 pi's. I can add 1 2 pi, okay? Or I could take this solution and add 2 pi. But there's an easier way to write that, because look at how my picture was. My picture originally was like this. So the easier way to write it is you could do that one, which is that angle right here is 3 pi over 4. And then to get to this one, from here to here, is pi. So I could write it as 3 pi over 4 plus n times pi. And that's That's the faster way to write it. So this is how I prefer you to write your solutions. If you can. If they're right across from each other like that, you can write them like this. If they weren't, let's say I had sine, for example. Sine is positive in these two quadrants, so if I had them in these two quadrants, they wouldn't be 180 degrees apart, or pi radians apart, so I couldn't write, I'd have to write it as two different equations. But in this one, since this makes a straight line, I can write it as one general solution. Oops. That's a more efficient way to write it. Next example 3. Find all the solutions in degrees. Radical 3 secant of x plus 2 is equal to 0. So first I want to solve for secant. So secant of x would be negative 2 if I move the 2 over radical 3. So remember, secant and cosine are reciprocals. So that's r over x, or the hypotenuse over the adjacent. This is a triangle that we know. You draw it out. Cosine is negative right here, right there, second, and third. That's what I wrote here. And the sides of my triangle, my hypotenuse is 2, my x side here is negative radical 3. So this is a 1, 2 radical 3 triangle. Okay? Reference angle. Reference angle is 30 degrees. So my first quadrant, or second quadrant angle, the first one I want to do, would be 180 minus 30, which is 150 degrees. The one in the third quadrant would be 180 plus 30 degrees, or 210. So those are only two angles, but I want all solutions. So I would have to take each of these and add a circle. Or add multiple circles. Add a circle, or add multiple circles, n circles. That's what I have here. So here's our solution. That, you see, I had to write in two different equations because they were not in quadrants that were diagonal. 4. Let me show you something else here. What if, when I was doing this, it wasn't a triangle that I knew? How would you do that? Well, remember inverses? You would do inverses. So let me show you how to do this with inverses. There's no inverse secant on our calculators, but there is an inverse cosine. So I know that the cosine of x is the reciprocal of that. So it's radical 3 over 2. So in your calculator, oops, not x, if you put in the inverse cosine of negative radical 3 over 2, you will get an angle x. And remember, for cosine, you'll get it in first quadrant or the second quadrant because it's positive there and negative here. So it'll be an angle in this quadrant. So that's what my calculator will give me, that angle right there. It won't give me the one in the third quadrant. You have to figure that one out. So let me just show you how you do that. Let me pull up my calculator and pull it over. First of all, a calculator, this is degrees, so I want to go in degree mode. So I go over here to degrees, push enter. I'm going to quit out of there. So I'm in degree mode. Inverse cosine, so if I do inverse cosine of negative, so down is, there's my negative, that's minus, that's negative. So negative radical 3. You can move the arrow over because if I do divided by 2, the divided by 2 will be under the radical 2 also. Divided by 2. And notice I got 150. So what I'm saying is this one's 150. So then from there, you would also then have to know, okay, I'm also negative in this quadrant. If this is 150, that's a 30-degree reference angle. 180 minus 150 gives me 30, so that'll be 30. So 180 plus 30 is my 210. So that's how you do it in your calculator, if it wasn't a triangle that you knew. So let's do some more problems. Find all the solutions in the interval from 0 to 360. So now I don't have to do the add so many ends. I just have to get it, make sure it's between 0 and 360 degrees. So cotangent of theta plus 30 degrees is equal to 6. So I know that this right here is the reciprocal of tangent. So it's adjacent over my opposite side instead of opposite over adjacent. But when you do this, and you do your picture, you might say, oh, that's not a triangle, I know. So here's where you have to use a triangle. Because if you drew this, you'd say, okay, 6 gives me, there's, whoops, I did that wrong. Tangent. You would say I'm in my first quadrant, or my third quadrant, and x is 6, y is 1, so 6 over 1. That's not a triangle, I know. So you would pick up your calculator, and you would put the inverse tangent of 6 in your calculator, make sure you're, or 1/6, sorry, in your calculator, and make sure you're in degrees, because cotangent and tangent are reciprocals. Remember, the tangent of an angle is 1 over the cotangent of an angle. So pick up your calculator and do inverse tangent of 1 over 6. So here's my inverse tangent of 1 divided by 6. And that's not inverse tangent. I was wondering, it didn't look right. Inverse tangent, I did just tangent, 1 divided by 6. Much better. 9.46 degrees. 9.46, rounded to 9.5. I already drew what quadrants I'm in. I'm in the quadrant 1 and also quadrant 3, and I don't know if I wrote it here. In quadrant, first quadrant, I don't think I wrote it here. But I'm in quadrant 1 and I'm also in quadrant 3. Okay, so in quadrant 1, my angle is 9.5. In quadrant 3, my reference angle is 9.5, so I have to do 180 plus 9.5. So in quadrant 1, my angle's theta plus 360, my angle here is 9.5. In quadrant 3, my angle is 180 plus the 9.5. Okay? So do the math. Subtract 30 from each side here on this one, and you have negative 20.5 degrees. And you say, okay, I'm done. But I want it between 0 and 360. Remember, coterminal. I can add or subtract whole circles, and I'm still at that same spot. So if I add a whole circle, I have one angle right here. My third quadrant angle, solving that, if I have theta plus 30 is equal to 180 plus 9.5, 189 minus 30 is 159.5. So there's my second angle. So those are my two angles, and I'm done. Because I only want between 0 and 360. If I wanted all of them, I could just add 180 pi, because they are in opposite quadrants. Okay, and you can see these right here. If I add 180 or subtract 180 from that, I should be at the other angle. Next one, find all the solutions. Now I'm in radians. So solve for secant. Secant of x then, add 7 divided by 2. 7/2. Remember, secant and cosine are reciprocal functions. Okay? So the cosine would be 2/7. So in your calculator, you put inverse cosine of 2/7. Make sure this time, though, you are in radians. So I'm going to pull up my calculator. Mode. I'm in degree mode from the last one. Go to radian mode. See how it's highlighted now? And I can quit out of there. So now I'm going to do the inverse cosine. Don't do the cosine. Inverse cosine of 2 divided by 7. Oops. Didn't get my divided by. Inverse cosine of 2 divided by, there it is, 7. 1.28. And that's what I have here. Okay? So, let me draw a picture. Cosine's positive there. Cosine's positive there. This reference angle here is 1.28 radians. So in the first quadrant, it's just 1.28 radians. In the fourth quadrant, here's 1.28 radians. So the angle in the first quadrant is 1.28. That's what I was saying. In the fourth quadrant, the angle is 2 pi minus 1.28. Put that in your calculator. 2 pi minus 1.28, and you get approximately 5.0. Let me just do it with my calculator. 2 pi, is it even pi? Minus that angle right there. See, 5.002140, so 5.00. And I'm done. I went to 0 to 2 pi. 0 to 2 pi. 2 pi is 2 times 3.14, which is about 6.28, so between 0 and 6.28. There's my 2 answers. Example 6, find the exact solutions. Interval from 0 to 2 pi. Solve cosecant. So I add 2 to each side. Remember, cosecant and sine are reciprocal functions. So the sine of this angle is 1/2. And I believe that's an angle I know, so I don't need my calculator for this one. Positive. Sine is positive in the first quadrant. It's also positive in the second quadrant. Opposite over hypotenuse. So my reference angle in radians is pi/6. So in the first quadrant, I'm pi/6. In the second quadrant, I'm pi minus pi/6, which is 5 pi/6. But that's this angle, not what x is. So here's what I said. Positive in quadrants 1 and 2, the angle in the first quadrant, your angle is pi/6. In the second quadrant, I said that your angle was 5 pi/6. Your angle is x plus pi/8. So this is what I want to solve. I want to move that to the other side. So if I subtract pi/8 and get a common denominator, which would be 24, I could write that as 4/24 pi, and this is 3/24 pi. 4 minus 3 is just 1, so it's 1 pi over 24. So there's the answer right there. Next one. Subtract, again, pi/8. So I have x is equal to 5 pi/6 minus pi/8. Common denominator here is again 24. So if I multiply 4 over 4 here, I have 20/24 times pi. And here I multiply top and bottom by 3. I have 3/24 pi. 20 minus 3 is 17. So 17 pi over 24. And there are my two answers, and I'm done. This is just 0 to 2 pi. If I wanted all answers, I would just add 2 pi n to each of those. Zero product property. Want to find all the solutions between 0 and 2 pi. We actually did one like this on the worksheet that we did. We had one that we factored, and then when we factored it, we did this zero product. Remember, two things multiplied together equals 0. Either the first one has to equal 0 or the second one. So that's what I'm solving. Solving 2 cosine of x is equal to 0, or radical 3 tangent of x minus 1 is equal to 0. So we're solving those. So cosine of x is negative 1/2. Tangent of x is positive 1 over radical 3. And I'm leaving the radical in the bottom for now. So let me draw pictures. I think pictures tell it all. Cosine is negative in the second quadrant and also the third quadrant. Adjacent and hypotenuse, so my adjacent side is -1, my hypotenuse is 2. So I hope you know that your reference angle, I'm in radians, is it's a 60° or pi over 3 is my reference angle. So let me do that. Cosine is negative. In quadrants 2 and 3, the reference angle is pi over 3. So in quadrant 2, I'm 2 pi over 3. And in quadrant 3, I'm 4 pi over 3. Okay? Tangent, let me draw that one now. Positive. Opposite over adjacent, opposite over adjacent. My reference angle is pi over 6. So I'm positive in quadrants 1 and 3. My reference angle is pi over 6. In quadrant 1, I'm just pi over 6. In quadrant 3, I'm 7 pi over 6. So there are my 4 answers. All 4 of these. And I wrote them in set notation. So the set. Slide 10, number 8. Cotangent squared of x is equal to 1. 3 cotangent squared of x is equal to 1. All solutions from 0 to 2 pi. Divide each side by 3 and take the square root of each side. When you take the square root, you'll have plus or minus. Radical 1 is 1, radical 3 is radical 3. So now I'm in every quadrant. Every single quadrant. Okay? Cotangent is adjacent side. So my adjacent side is 1. My opposite side is radical 3. So I'm in all quadrants. My reference angle is 60° or pi over 3. So in the first quadrant, it's pi over 3. Second quadrant, 2 pi over 3. 4 pi over 3. And 5 pi over 3. So pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. Okay? 1/3, 2/3, 3/3, which we don't have, 4/3, 5/3, 6/3. So we just count around. So pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. And there they're written as one set. Next one. This is also very similar to one that we did on the worksheet. We need to factor this. So do 2 sets of parentheses. So we do the 2 sets of parentheses, and 2 cosine of x and cosine of x go in my first positions. and I know it's going to be 2 and 1 or 2 and 1, with either both of them being positive or both being negative, because that's positive, so they both have to be positive, both have to be negative, but that's negative, so they both have to be negative. And hopefully you realize that it factors like this. And then we know that 2 cosine of x minus 1 is equal to 0, or cosine of x minus 2 is equal to 0. So when I do that one, positive in the first quadrant and the fourth quadrant, with my adjacent side being 1 and my hypotenuse being 2. So my reference angle is pi over 3. So in quadrants 1 and 4, my reference angle is pi over 3. In quadrant 1, I'm pi over 3. In quadrant 4, I'm 1, 2, 3, 4, 5 pi over 3. Okay, so that's this here. Now if you do cosine right here, or I'm going to do that one right there, solve it, cosine of x is equal to 2. Can't do that. Remember, this is the ratio. Cosine is x over r. And so could I have an x being 2 and an r being 1? No, you cannot. Cosine can only go up to 1 and down to negative 1, just like sine. So we throw that one out. So these are our only answers. The one from 2 cosine of x minus 1. Radical 3 sine of x plus cosine of x is equal to 0. I have a couple different trig functions. I can make one trig function. If I divide by cosine, divide everything by cosine, I will have one trig function, which is tangent. And if I divide that by cosine, it's still 0. So I have radical 3 tangent here, I have 1 here, equals 0. And now it's just like the other problems. Tangent of x is negative 1 over 3, or radical 3. Tangent's negative. In the first or second quadrant and fourth quadrant, tangent opposite, to write it the right one, opposite over adjacent, opposite over adjacent. Okay. Reference angle there is a 30-degree or pi over 6 reference angle. So quadrants 2 and 4, pi over 6. So in quadrant number 2, it's 5 pi over 6. In quadrant 4, it's 12, 11 pi over 6. Because 12 6s here minus a 6, which is 11 6. 2 answers. Next one. Example 11, trig identities to solve the equation from the interval. Different trig functions. I have sine squared and I have cosine. Remember, sine squared plus cosine squared is equal to 1. So I could do a substitution here. And this one is like that one on the worksheet. So instead of sine squared, I can call it 1 minus cosine squared. So that's what I did. 2 times 1 minus cosine squared plus cosine minus 1. Distribute the 2. Combine any like terms. 2 minus 1 is 1. I don't like having the squared being negative, so if I multiply each side by negative 1 and then rearrange it, this becomes a negative, that, or positive, that becomes a negative, that becomes a negative. So positive, negative, and negative. Now I'm going to factor it. Cosine of x and 2 cosine of x will be in the first positions of my parentheses. I know it's either plus, it's a plus and a minus, it has to be. So you know they have to each be 1. You have to decide, is this a plus or is this a plus? When you do it, negative 2 plus 1 is negative. And then let's solve it. 2 cosine of x plus 1 is equal to 0. So cosine of x is negative 1/2. And if you do the other one, did I do the other one over here somewhere? Right there. Or cosine of x is equal to 1. Let's draw them out. Cosine, negative, over in the second quadrant and the third quadrant. Adjacent side, hypotenuse. So my reference angle here in radians is pi over 3. So I'm in quadrants 2 and 3 with a reference angle of pi over 3. So in quadrant 2, I'm 2 pi over 3. In quadrant 3, I'm 4 pi over 3. Right here. Okay. Cosine of x is equal to 1. Again, remember that that's adjacent over hypotenuse, so it's 1 over 1. Right there is where x is 1, and r is also 1. And that's the only place. So my angle is 0 radians, or 0 degrees. So those are my 3 answers. 0, 2 pi over 3, 4 pi over 3. And I said between 0 and 2 pi, including 0.